This next video is going to look at our second learning target from section 9.4, which is now to solve a trigonometric equation. So basically what we're doing is just a lot of what we did in learning target 9.4a, but now we're just going to look at some different types of problems that you're going to have to solve that have your inverse trig functions in them. So the first type of equation that we're going to look at is one like here in example 2. So they want us to solve the equation the cosine of theta equals 3/4, where theta is going to be between 270 degrees and 360 degrees. So we're going to solve it similar to how we were solving those last ones. So we have to get that inverse cosine. So in order to solve for the theta, we need to move that cosine over. To do that, we do the inverse cosine. So theta is going to equal the inverse cosine of 3/4. Now it looks just like the last problems that we did. So thinking back to what we did in example 1, 3/4 is not on that chart that I gave you. So this is one where you just type it into your calculator and you do that inverse cosine of 3/4. Now you do want to make sure that because the restriction they put on the domain is in degrees, that means that's what they want the answer in. So you're going to want to make sure that your calculator is also set in degrees. So once your calculator is set in degrees, just go ahead and type in the inverse cosine of 3/4, and you should get an answer of 41.41. But now, that can't be my final answer because that answer is not between 270 and 360. So if I want it between 270 and 360, that means that I'm going to be in the fourth quadrant. So that 41.41 is actually the reference angle of this overall angle that I'm looking for. So I'm looking for this angle here. Well, because it is in the fourth quadrant, we learned the other day that to solve this, you're going to do 360 minus that reference angle of 41.41. So when I subtract those, I get an answer of 318.59. And there is my answer that would give me, if I took the cosine of the 318.59, I would get something that is very close to 3/4 because we had to do some rounding. So that's why our final answer is going to be just pretty close to the 3/4. So let's look at now a second example like this, where I have the sine of theta equals negative 0.4, where theta is between pi and 3 pi over 2. So this time they're asking for radians. So now when we go back to our equation, remember we want to get rid of that sine. So to do that, we're going to do the inverse sine. So theta is going to equal the inverse sine of negative 0.4. So now before we type it in our calculator, we need to make sure that our calculator is set in radians. For the last problem we had in degrees, so now we need to switch it back or switch it over to radians. So once you've got your calculator set back to radians, type in the inverse sine of negative 0.4. And when you do that, you should get an answer or get theta to be negative 0.41. But again, negative 0.41 is not between pi and 3 pi over 2. So when we're looking at this, pi and 3 pi over 2 would be the third quadrant, so I want something in there. So my reference angle is actually going to be then the 0.41. So I want to figure out what this angle is. So when I'm in the third quadrant, that's when I do the pi plus the reference angle. So the pi plus 0.41. And when I do that, I get 3.55. So there's my answer in radians. So I get an answer of 3.55. So now let's look at a second type of example where you're going to have to solve for or use an inverse trig function to solve your equation. And that's one where they're asking you to find the measure of the angle in the triangle. So when solving this triangle, we need to remember our right triangle trigonometry. So if it helps, think of your SOHCAHTOA and write that maybe across the top of your page to help you remember which trig functions you use when you're given different things. So back to our triangle, my angle's down here at the bottom. So the 6 is touching the angle, so that is my adjacent side. The 17 is straight across from the angle, so that is the opposite side. So looking at SOHCAHTOA, I know that the tangent uses the opposite and the adjacent. So I'm going to set up my trig equation. So the tangent of theta is equal to the opposite, or 17, over the adjacent, or 6. So now there's my trig ratio that we looked at in section 9.1. So now let's solve this trig equation like we did in example 2. So to get rid of that tangent, I have to move it to the other side. To do that, I have to do the inverse tangent. So I do the inverse tangent, so tangent to the -1, of the 17/6. And when I do that, I type that in my calculator. With these types of problems, we're going to be working in degrees, so make sure your calculator is set in degrees. And so I type in, after the calculator's in degrees, I type in the inverse tangent of 17 divided by 6, and I find that theta is equal to 70.56 degrees. Make sure you put that degree mark to show that it is degrees. And there's the degree of that angle that is formed in the bottom part of this triangle. So now let's look at another example of this. So the second triangle I have, my theta is now located in the top part of the triangle. So based on where that theta is at, let's identify the sides that were given to us. So the 9 is across from the right angle, so that is always our hypotenuse. And then the 4 is next to the angle, or it's touching that angle, so it is adjacent. So if I look at my SOHCAHTOA, I use adjacent and hypotenuse with the cosine. So when I write my equation, I get the cosine of theta equals the adjacent, or 4, over the hypotenuse, or 9. So then to solve for theta, I go ahead and do the inverse cosine. So theta is equal to the inverse cosine of 4/9. Again, we'll still be working in degrees, so keep your calculator in degrees. Do the inverse cosine of 4/9, and you'll get that theta is equal to 63.61 degrees. And there's the answer, or there's the angle that is in the triangle with a side of 4 and a hypotenuse of 9. Let's now look at one last example. It's still an example of learning target 9.4b. But this time it's a story problem, so you have to pick out the information from the story problem to make your triangle and then solve an equation that you can form from the triangle. This problem says that if you have a building that is 52 feet tall and it casts a 23-foot shadow, what is the angle of elevation of the sun? So when we have this, first we want to do is draw a picture. So if here's my building, and it's 52 feet, so I'm going to label it with 52. I know then that it casts a shadow, so I've got some shadow on the ground that is 23 feet. Well, now keep in mind, if the shadow is going, in my case, to the right, that means my sun is over here off to the left. So always make sure that you have your sun in the right spot, because now it wants to know the angle of elevation to the sun. Now remember, angle of elevation means it's from the horizontal and up. So I'm starting at the tip of the shadow and I'm going up to the sun. And it wants to know what this angle that is formed down here at the bottom is. So that's where my theta is going to go. So now, using that and my information about SOHCAHTOA, so I'll write that again at the top, so we have that available to us. Oops. So there's my SOHCAHTOA. From the angle that we're looking for, the 52 is the opposite side. The 23 is the adjacent side because it's touching the angle. So the trig function that uses the opposite and the adjacent is the tangent. So the tangent of this angle that I'm trying to figure out is equal to the opposite side, or 52, over the adjacent side, or 23. So now to finish solving for my theta, I'm going to do the inverse tangent. So theta is equal to the inverse tangent of 52 divided by 23. And now, again, I'm just going to type that in my calculator, make sure the calculator is set in degrees. And when I do that, I get that theta is equal to 66.14 degrees. And there's my answer. So there's the angle that the line of the sun makes with the ground.